What's up, guys? It's Andrew here. Today we're back with another USACO upload, and today we're going to be doing the 2017 December contest in the Silver Division. It's going to be problem 1, my calculate my homework, so without further ado, let's get into it. Alright, so let's just start reading here. So, in our bovine history class, I don't know what kind of history class that is, where you learn, cow history. You have been given a rather long homework assignment with n questions. Alright, we can see that n here is going to be pretty hefty at the end of the day. It goes up to 100,000, each graded with an integer score in the range of 0 to 10,000. Okay. So, as is often customary, your teacher plans to assign a final grade by discarding a question on which you received the lowest score. Okay, so how does she calculate the final grade? Well, first part, she takes out or discards a question where you receive the lowest score, so lowest scoring question, and then averaging the remaining scores together. Okay, so basically, you get an array of numbers, or it seems here, if we go down to the sample input, we get an array of numbers, array of n numbers, and each of these numbers represents a point value for a question. And in this case, we want to calculate the final score or the grade by discarding the question with the lowest score and averaging the rest. But wait, we also have to consider that your pet cow Bessie has just eaten your answers to the first k questions. Okay, so k could be as small as 1 or as large as n minus 2. So keeping these values in the back of our head is going to be good when we start coding later. Okay, so after Bessie has eaten our k questions, our teacher believes her story, okay, and agrees to grade the remaining non-eaten questions, part of the assignment, same way as before. Okay, so basically we're going to take out k questions each time, and k is going to increase. And again, k is in the range of 1 or n minus 2, or n1 to n minus 2. And after we remove k questions from the start, our teacher is still going to get our score or our grade the same exact way, or by removing the lowest scoring question and averaging the rest. Okay, so please output the values of k, which have earned you the maximum possible score according to this grading scheme in sort order. Okay, so k can actually be multiple values that can achieve the same maximum possible score. Okay, so let's take a look at our input-output formats here. First line input contains n, and the next line contains the n homework questions. Okay, it seems pretty simple. And output, one value per line, all values of k which have earned you the maximum possible score. Okay, so it seems that this one is 2, but it says that one value per line, so all values of k. So this is not always going to just be one integer output. It can be multiple, so we have to keep that in mind as well. Alright, so now that we have the question pretty much down to a science, we can start, trying to figure out how we get the sample output from the sample input. So let's just work that out real quick. Okay, so I have all the numbers drawn out over here, and let's just work this out. So we have n, which is 5, so we have 5 values here. That makes sense. And then, okay, let's see how we get the sample output here. So what they say is that if Bessie eats the first 2 questions, the remaining scores are 9, 2, and 7. Removing the minimum and averaging, we get a final grade of 8, which is the highest possible. Okay, so let's see what they mean. So let's just start when k equals to 1. Alright, so if Bessie eats the first question, that's getting rid of the 3. Now we have 4 questions left, and again, the teacher wants us to get rid of the lowest scoring question and then average the rest. So in this case, we can obviously see that 1 is the lowest scoring question, so we just temporarily get that out too. 9 plus 2 plus 7, do the math, that equals 18. So then 18 over 3 equals to 6. Alright, so 6 is what we get if k equals to 1. So if we put 6 right here. Alright, so and then let's just try if k equals to 2. In this case, that's what they think is going to be, or that's what they put as the sample output. So we know it's going to correct. Let's see what happens. So if k equals to 2, then we omit the first 2, and then we see which one's the minimum out of these 3. In this case, it's going to be 2. And then 9 plus 7 equals 16, divided by 2 remaining questions, which is equal to 8. So yeah, in this case, 8 is going to end up being the maximum possible. If we delete more, questions, we're not going to get any other greater possible score. Alright, so that pretty much makes sense, but now we have to try and figure out how we're going to implement this into a program. Okay, so since this problem heavily involves summing things up and to find the average, as well as sorting, which is probably used to find the minimum throughout these sets of scores in which k scores are going to get removed, we need to use prefix sums. So if you don't know, prefix sums is basically a summing concept for, I guess, summation purposes and silver and above. And basically they allow us to extract a compiled sum of data from an array of numbers of n time, instead of having to, say, sum each sub-array each time k scores get removed. So prefix sums is going to allow us to calculate the average within O of n time. So it's going to be a lot quicker and it's not going to time out. So this is why using prefix sums is important. Now, so just to explain and go into depth on how prefix sums work. So each index is going to be the summation of values of the array until that point. So if you don't know what that means, I'm just going to draw out the example real quick. So we have 3, 1, 9, 2, 7. Those are the scores. And although prefix sum sounds like this confusing summation math concept, it really isn't. It's basically just summing up the numbers in an array until that point. So here, Alright, so here, at this point in the array, we only have one number or one score. So in this case, this sum is going to be 3, because there's only one number. So 3 plus itself. So 3 plus nothing else to add is going to be 3. Now we have 1. So now we have to sum this subarray of numbers, because we are in our second index of prefix sums. So in this case, we get 4, because 3 plus 1 is 4. Now, all we need to do is continue adding up. So 4 plus 9 is 13. 13 plus 2 is 15. And 15 plus 7 is 22. So in this case, this would be our prefix sum array, because in this case, every number is a sum of the total numbers at that point. So for example, 3 is 3 plus nothing. 4 is 3 plus 1, 13 is 3 plus 1 plus 9, 15 is 3 plus 1 plus 9 plus 2, and 22 is 3 plus 1 plus 9 plus 2 plus 7. So that's how prefix sums work. Alright, so, and this is going to be the general algorithm or implementation for prefix sums. Basically, we've set our prefix sum first index to the first number in the array, because, again, there's only one number or one score in this subset, and then we just continue adding from there, and this is basically an incremental approach through a loop. So yeah, this is going to allow us to basically sum these numbers up and calculate the average at O of n time. So yeah. Alright, so we also need to do again, we have to and remove the lowest scoring question. To find the lowest scoring question, we need to find the minimum of each subset after k scores have been omitted. So how do we do that efficiently? Well, we can use something called suffix minimums. So to omit the minimum of each subset after k scores are omitted, then if we sort and then extract from there, that's going to take too much time, because as you know, sorting is going to take a lot of time in your compiler, especially in Silver with those hefty numbers. So we need to use something called a suffix minimum. So this is very similar to the prefix sum concept, as we're again incrementing or like saving a value throughout multiple subsets and putting it into one array. So yeah, that's how we're going to do this. So here is basically the implementation for our suffix minimum array, to fill up our suffix minimum array. So basically, it looks kind of confusing right now, but I'm going to go more into depth of how it works. So by erasing all this, and boom. All right. So how does our suffix minimum array work? So I have one last slide here which shows the chart of all the arrays. So our original array is going to be 3, 1, 9, 2, 7, and here's the index up here. And you may notice that our suffix minimum numbers are a bit funky, but let's see how they work. So we have our original array 3 1. Sorry, I don't memorize it. 9 2 7. And now we need to compute the minimum after k numbers have been removed. Well, so in this case though, we need to start from the very back, from 7, because in this case our k values are going to be taken away in this direction. So, however, to calculate our minimums, we need to take the numbers that are left. So in this case, finding the minimum is going to go this direction. So it's going to have to be a backwards incrementation. So in this case, it would just be decrementing. Trying to find my vocabulary there. So yeah, how do we calculate these suffix minimums? Well, let's take our first subset. Again, we're starting from the back. So 7. What's the minimum number out of all of these numbers? Well, it's only one number, so it has to be 7. All right, next we have two numbers. After, in this case, k equals 3. So yeah, I should probably consider k in the beginning. So let's just say that k equals to 4. In this case, remove the first 4 numbers here. Well, in this case, there's only 7. Or there's only 7 is left. So in this case, 7 is going to be the minimum of the only number in the subset. So yeah, in this case, the suffix minimum, in this case, in this index is going to be 7. Well, what if k is equal to 3? Well, in this case, we remove 3, 1, and 9, and we're left with 2 and 7. What's the minimum in this case? Well, in this case, it's going to be 2, because 2 is less than 7. Simple math. In this case, now that suffix minimum value at that index is going to be 2. Alright, now let's just say that k equals to 2 now. We only remove 3 and 1. Well, in this case, we now have 9, 2, and 7. So which one is the minimum out of these 3 numbers? Well, it's still going to be 2. Same goes for k equals 1. We only remove 3. Now we have a subset of 1, 9, 2, 7. Which one is the minimum? In this case, 2 is going to be dethroned for 1. And 1 is going to be that suffix minimum there. And the reason we call it suffix is because, again, we're going from the back, because after k scores are omitted, we have to find the minimum out of these remaining values. And finally, at the beginning, where no numbers are omitted, which one is the minimum? In this case, it's still going to be 1. Oops. Alright, so that's how we build our suffix minimum array. Alright, so now with these two concepts in mind, our suffix minimum, to build a suffix minimum array, and a prefix sum array. And again, the prefix sum array is going to allow us to average things out easier, and our suffix minimum array is going to allow us to omit the minimum a lot easier. So yeah, with these two concepts in mind, we can start coding. Alright guys, welcome back to my IDE, the IntelliJ, the one and only. And basically what I've done is created a new Java file, and I've just done my input-output, buffered reader, print writer. And I've also read in the input, so n, I read it in as a simple integer.parsent, so integer, and for basically the array of numbers they give you to represent the scores of all the questions, I read that in as well in a integer array, and basically I've read it in using string tokenizer and yeah, all that stuff. And what I've also done is that I've copied the code from my slides, or basically I just took the code, my own code, for my prefix sum and my suffix minimum, and put the two methods here. And these methods are really just going to basically be the core of our code here. Other than this, it's not going to be that complicated. So yeah, these are the methods. The code is all right here. You can pause the video if you want to reference it. So yeah, from here, we are going to go into how we're going to print the answer. Alright, so first of all, we need to create a set. Now, why a set? Well, that's because if we go back to our problem here, it says that please output one value per line, all values of k, which have earned you the maximum possible score. Well, to figure out all values of k, we have to use a set, because sets allow us to basically clear the entire thing out if we don't need it, and add more from there. And we need to use that function in this case, because say that we have 3 values of k that amount to 1 value, and then another value of k that's only 1 value of k that amounts to a greater value. Well, in that case, we need to clear those 3 values and use only that k value that gets us the maximum possible score or grade. So yeah, in this case, we need to declare a set. We can say it's going to be an integer set. We can say k val k, or the values of k that amount to the maximum possible grade. So this is going to be a new hash set. Oops, I can't type. Integer. And then we're also going to again call our prefix sum and suffix min methods that allow us to basically, again, first prefix sum is going to allow us to average. So as you know, average, it means getting the sum and dividing by the number of values. So in this case, this is going to be come in handy. We're going to use to find the average after we omit the minimum. And to find that minimum, we need to use the suffix min to create an array of minimums. So in this case, let's just call these two methods and put them into two arrays. So you can say int mins equals to new int n, and then int prefix sum. Oops, I should not have pressed tab. Int prefix sum equals to new int n as well. And then from here we can copy, or not copy, call our two methods. And again, these are just going to reference the two variables that we read in from the input that they give us. So this is prefix sums, and then we can do fill suffix min. I can't spell. Fill suffix min. Again, just going to use the same variables. Again, if we go back to our chart over here in our slides, you can see that all of these two arrays are extracted from the original array. So yeah, go back, and suffix, mins. There we go. So yeah, now that we have called our two methods and put them into arrays, we can actually go about our general problem-solving process. And so yeah, let's first set a variable to hold the maximum. And again, this has to be a double, because when you're averaging things out, sometimes if you use the integer, it's going to, I guess, mismatch. Because again, as you know, integers, when you divide something, it basically negates any decimal, or it basically like cuts off any decimal values you have in the case of division. So you don't want that in case of comparing, and you never know which one's going to be greater if, you know, some decimal points are left off. So yeah, we're going to use double for max. And we're pretty much going to use double for a lot of values going in through here. So first we need to iterate through values of k, because again, Bessie is going to eat k values, k questions. And this value, again, if we go back to our problem, is going to range, oops, that is wrong tab, is going to range from, let's see here, small as 1 and as large as n minus 2. So we need to iterate through those values. So again, k is going to start at 1, and then k is going to be less than or equal to, oops, I can't type, n minus 2. And from there, we increment. Alright, so now we can declare a double, let's just call it temp, that's going to hold our prefix sum value. So why do we need to subtract here? Well, in this case, let's see, hold on, let me finish typing here. So we need to subtract prefix sums with the prefix sums of k minus 1. And then we have to do this minus temp minus suffix mins k. Alright. Oops. Sorry. Minus equal mins k. Alright, so let me explain these two lines. So this temp is going to basically allow us to calculate an average after a k questions have been eaten by Bessie. So first, what do we do? So first, we need to get the sum of values up at that point. How do we do that? Well, we take our prefix sum array. So let's use prefix sum array to calculate to omit questions that Bessie has eaten. Because if you know, again, our prefix sums is going to store the the summation of all the question point values that we got. And since Bessie has eaten some of them, we need to take those points and subtract it from the total. So that's what we're doing here. And then I should probably comment these as well. So create set to what is it again? Oh yeah, store max k values that result in max. Clear if there is greater. Alright, so now, and from here, we also have to subtract our value from our suffix minimum, because, again, the teacher is going to continue with her grading strategy and omit the smallest score. So, again, we have to omit the K questions that Bessie ate, and then we also have to omit the low scoring question. That's where our suffix minimum array comes in. Alright, cool. Now, we have to calculate the average after we got our combined total. And again, calculating average, let's just say average equals to nubs, sorry, not nubs, temp divided by n minus, so k plus 1. And that's going to be, so again, temp is just going to be our combined total. And again, to calculate average, we need to divide by a number of values we have. In this case, we start with n values, but then we have to remove the questions that Bessie eaten, plus 1 that we have removed, which is the lowest scoring one. So yeah. So now we have to see whether this k value is worth storing into our set and returning, or printing, because again, we only have to print out the k values that result in the highest possible. So how do we know that this average is highest possible? Well, we have to compare it to our current max. In this case, our max is at 0, so we have to compare it. So average is, oops, I did not mean to press that. Max is greater than max. Well, we have to set it to our max. So max equals to average. Then we have to clear our set of our current k values that we thought were going to be the greatest, or what the code thought they were going to be the greatest. We didn't name it say, we named it val k. Okay. And then, so we have to dot clear, and then we also have to add our k value. Alright, so else, that was a bad voice crack, my bad. Else if, sorry. So what if it's equal to, well, it says that, again, if we go back to our problem here, it says that please output one value per line, all values of k which have earned you the maximum possible score. In this case, it's all values. So what if it's the same maximum possible score? We don't know if it's going to be we don't know if it's going to be the 1, but we still have to store it just in case it is. So when you say if average equals to max, I did not mean to click that either. Okay. Then we add it to our set. Oh, I forgot to add the values here, my bad. Add k, oops. And then else if. Alright, so yeah, and then, yeah, else if, and then after we add it, we can say, I think that's it, yeah, that's it. Alright, now, so this is basically our general problem solving, I guess, walkthrough for this part, besides the methods. And now, after we're done with that, we can try printing out the answer. So after we build our set here, what do we need to do? Well, in this case, we need to print all the values of k that result into maximum possible score. So we can say int k in val k pw.print line k. From there, we can do pw.close close just to close out our reading and output methods up here. And there we go. That's pretty much the code. That's I'm going to scroll through it one more time explaining everything. I should probably put comments here if you guys want them. So this is prefix sums to calculate sum for averaging, for faster averaging. And here is filling our suffix min array for finding lowest scoring question. Alright, cool. So yeah, that's pretty much code. Let's go through it one more time. Read an input, then from there we call our two methods down here, and from there we have to go through our k values to see which ones are going to result in the maximum possible. And to store the k values, we created a set. And yeah, there we go. That's the problem homework of my homework. And so yeah, let's go to our grading server and let's plug it in. See how we do. Alright, so welcome back to the grade server. I'm on the grade server here and I've just plugged in my solution. And let's see how we do. Alright, so it says grading in progress. It's taking an awfully long time. Oh, 3 there. 4, 5. All green, please. Let's go. And alright, 10 test cases in the bag. Let's go. Alright, so that was my homework. Pretty elegant solution, I would say. We used two methods that really came in clutch at the end. So yeah, thank you guys so much for watching. I recently just hit 100 subs, and I can't thank you guys enough for that. It's really been crazy, and I never imagined I would make it to this point when I started my channel. So yeah, I really, you guys mean the world to me. I wouldn't be here without you. So yeah, hopefully we can hit 200 subs by the end of the year. That's a goal, I guess, or more. But yeah, so I have plenty of other videos in store for you guys. You can also comment down below which videos you want to see related to competitive programming or USACO problems or anything like that. So yeah, I'll see you in the next video, guys. Peace out.